Okay, so my previous, it was not output. So I can start from the beginning, no? Now? So hello, so there is a problem in the audio. Okay, so we can start from the beginning or from now?
Yeah, from the beginning.
From the beginning. So there was a problem in the audio, so I will start from the beginning. So welcome to third live session, that is the final live session of the course, Computer Vision and Image Processing, Fundamentals and Applications. This is the third and the final live session of this course. So I have received some questions in the Google Doc file. So I can see all the questions and I will try to answer all the questions. And if you have any questions, you can put or you can write your questions in the chat box one by one, and I will try to answer all the questions. So be online. So first I will see the questions that is available in the Google Doc file. So first I will answer all the questions, and after this I will go to the chat box. So first I will see the questions in the Google Doc file. So it is the Sheetal Jadhav. So she mentioned about what are research trends in image processing for any real-time application like biomedical. So this is one important question, that is the real-time application of image processing, real-time application of computer vision. So I can give one example. Suppose that real-time video surveillance, the video surveillance. So tracking of people, tracking of vehicles, or maybe we can consider tracking of objects. And in this case, we can consider the input is from the CCTV camera, or maybe any other camera, and the tracking, or maybe the recognition, or maybe the classification, or maybe the detection we can consider in real time. So this is one important applications. Other applications may be something like the gait recognition. Gait means walking style. So that is also the real time application. Another one is the gesture recognition. That is also one important application in the real time. And gesture is mainly the movement of the hand and the other body parts, maybe the facial expressions. So recognition of real time facial expressions. So this is also another important applications for human computer intelligent interactions. Human computer interactions. There are many applications in the biomedical image processing, or in biometrics also there are many applications, real-time applications. So you can see all these applications. Even in the forensic also there are some applications, real-time application of image processing and the computer vision. So this is the first question. Second question is, CERT. Sir, you have put a lot of effort, time in developing. Thank you for offering the NPTEL course. Very impressive. The image processing part of the course quite interesting. Okay, this is about the appreciation of the course. So this is not the question. So I think it is okay. Thank you for this, your comments. So I am trying my best to include most of the topics in the course, but it is really very difficult to put all the contents in a 12 weeks course. So that is also very difficult. So the third question is by Shart. Kindly suggest a good book for implementation of image processing system in Python. So there are many good books, but if you see in online also you can get some books like image processing by Python, Sandipan Day. I have seen that book in the online. So you can see this book in the Google, the image processing by Python by Sandipan Day. or there are many other books that you can see. In online shopping, you can get these books. Another question is by Cert. Is knowledge of low-level coding C, C++ and DSP SIP coding is required for implementation of image processing system? For working in image processing industry or high-level coding, Python is sufficient for implementation of image processing system in industry. So this is also very important question. This is also a very important question. That question is mainly that implementation of image processing algorithm, computer vision algorithms by Python. I think that is sufficient. So if you know the OpenCV Python, so with the OpenCV Python you can do the most of the things. But also if you see the basic programming like C, C++ or maybe the DSP programming, you can do, but for the basic systems, the basic algorithms, then your understanding will be clear. Because in most of the cases, you have to write all the programs, all the codes you have to write yourself, in DSP programming particularly. And particularly in image processing also, it is very difficult to write in the DSP processor kit. So that is why for industry, I think better one is the Python, OpenCV Python, that is better. That is the best one. Better means I can say it's the best one as compared to C++, C or maybe the DSP programming. But for understanding of the basic concept, you can learn C, C++ or maybe the DSP programming, you can learn. But for industrial applications, I think the best one is the OpenCV Python. So now I have finished the questions of the Google Doc file. Now I will see the questions from the chat box. No audio, no audio. Now I think it is rectified. So the one question is by good evening, Srini Norris. So I think my TA will give the solutions of the assignments. So I told them to upload the solutions of the assignments. So I think that will be done. So now it is the 10th week of the course. So maybe after 2 weeks, all the assignments will be completed. And after this, they will upload the solutions of the questions, the assignments. So if you have any questions, then you can ask, you can write your question in the chat box. I am available here. Okay, I have received one question, ISS. The book is Sandipan Day, that image processing by Python by Sandipan Day. The next question I have received, that is the Mohesh Bura. If we were given gradient in magnitude and direction in matrix, how do we convert it to single value and degree? Please help us. So mainly suppose that is the concept of the gradient image. So suppose if I consider one image, and suppose if I consider some marks, suppose Sobel marks is available. So there are two marks. One is for the determining the horizontal gradient, and another one is for the determining the vertical gradient. So with the help of the marks, first you have to determine the horizontal gradient, and after this with the another marks you have to determine the vertical gradient. After this, the gradient magnitude is root over gx square plus gy square, that is the gradient magnitude. So gx means the gradient along the x direction and gy is the gradient along the y direction. So from these two information, one is the gradient along the x direction, another one is the gradient along the y direction, you can determine gradient magnitude. So m is equal to root over gx square plus gy square. So that is the gradient magnitude. And also you can determine the angle theta. Theta is the direction of the edge normal. Theta is the direction of the edge normal. So that is equal to tan inverse gy divided by gx. So I am repeating this. The theta is the direction of the edge normal. That is equal to tan inverse gy divided by gx. So with the help of these two formula, you can determine gradient magnitude and the direction theta you can determine. So this is a question from Mohesh Bura. So in my slide I have already explained how to determine the gradient magnitude gx and how to determine the gradient magnitude gy. So from this we can determine the gradient magnitude m. So m is equal to root over gx square plus gy square. So this is about the question. So next one is the Nilesh. Good evening. So good evening. So I think you have enjoyed the course. So already we have completed 9th week of the course and remaining 3 weeks. So I think you have enjoyed the course. So first part of the course already I told you, that is about the image acquisition and something like the camera and also the concept of the random test from like this. The second part is the image processing, and third image processing and the feature extraction, and third part is the machine learning, that because we have to go for classification, we have to go for recognition in a computer vision setup. So third part is machine learning, and finally I will discuss some of the applications of computer vision. So this is the outline of the course. The first part is the image acquisition part, second part is the image processing part and the feature extraction, and third part is the machine learning for object classification, object detection, and also object recognition. So Mohesh Bura, it is okay, thank you. Next one is the Rajendra Singh. Sir, on the internet different version of the operators are given. Which version to use in the exam? So I am not getting this point. Different version of what? Different version of the operators. Operators means I am assuming that you are asking about the Sobel operator, Prewitt operator, or maybe Robert operator. So I think whatever I am giving in the PPT, that is the standard one, because I have seen my book and many other books I have consulted, and based on this I am making the PPT. So better to see my PPT and also the standard books like image processing by Gonzalez, and one of my book is also available, image processing, computer vision and image processing. My book also you can see. So based on this you can find the solution of this. That one is the operator. Operator means I am assuming that you are asking about the Robert marks, Prewitt marks, and the Sobel marks. Okay, the Rajendra Singh, you meant about the gradient operators. Gradient operator is the that I discussed about this. The Sobel, one is the Sobel marks. One is the simple Prewitt marks. The Sobel marks is -1, -2, 1, 0, 0, 0, 1, 2, 1. That is a standard marks. That is a standard marks. That marks, you can see that the marks in the book by Gonzalez, image processing by Gonzalez. And in the PPT also, my PPT or in my videos, you can see that marks. So for gradient magnitude, you can use the Prewitt marks, or maybe the Sobel marks, or maybe the Robert. But Sobel is the most important marks in image processing. So with the help of the Sobel marks, there are two marks. One is the determining the horizontal gradient, another one is the determining the vertical gradient. So these two marks we can consider. So there is another question by Prashant Purela. Sir, in the assignment, question number 8, answer given by team is none of will give the marks. Sir, in the assignment number 8, assignment number 8 of which assignment I don't know, answer given by team is none, will give you marks in that one. So if you have any questions, if you have any problem in that question, you can send a mail to me and copy to TS, my TS. So just explain your problem, and if we find that problem is your question is genuine, then also we can re-evaluate the questions. There is a provision of the re-evaluation of the assignments. But I feel it is okay. So you just send the mail to TS and copy to me, then I can understand what is your question regarding the assignment. Okay. Another one is Jots. Sir, in your lecture number 17 slide, it is given that homomorphic filter uses low pass filter, but all other source showed high pass filter. I have ticked for low pass filter, but it is not wrong. It is got wrong. So again, this is the problem of the assignment. So just you send your question to my TS and copy to me. If you are correct, then we can do the re-evaluation of the assignment. That is possible. But I think the answers already checked by my TS. It is okay. So, but I think better to send one email to my TS and copy to me. And based on your request, I can check the question again. And if you are right, then we can go for rechecking or re-evaluation of the assignment. That is possible. So regarding the marks and all the concepts, basically I am following my book. This is a standard textbook. My book is a standard textbook. It is recognized as a textbook in computer vision and image processing. In many outside university, abroad university, they are using my books. So you are writing again, just sir, can we get your mail ID to CC to your the question? So my mail ID, it is available in my website. So you go to the EEE department, Department of Electronics and Electrical Engineering, IIT Guwahati. And after this, you can see the faculty name. So all the faculty members are available. So you can see my name there. And if you click there, you can see my web page. So you can see my home page, and in the home page, you can see my mail ID. So you go to the website, the EEE department in IIT Guwahati. In IIT Guwahati, you have to go to the website and you see the Department of Electronics and Electrical Engineering, and from that web page you can see the faculty names, the faculty members name, and my name is there. So you click there, you can see my home page. From the home page you can get my mail IDs. So you can CC the question to me, and the question you can send to my TS and CCing to me. if you have any questions, then you can put your questions in the chat box. I am available here. So this is the final live session of the course, Computer Vision and Image Processing, Fundamentals and Applications. So another question I am receiving, that is, sir, how gradient operator work with image? So again the question about the gradient operator. So gradient means you are finding, suppose the pixel, one pixel is the high value, another one is the low value, some pixel value. So that gradient, what is the sense of the pixel value, that you can find with the help of the gradient information. So suppose one edge or the boundary is present in an image. So edge means high frequency information because the sudden sense of the intensity value. So if I want to determine that the position of the edge, then you have to find the gradient of the image. So already I told you, so we have some marks, standard marks, like the Sobel marks is a standard marks. So there are two marks, Sobel marks. One is the marks for the determining the horizontal gradient, and another marks is the marks for determining the vertical gradient. So with the one marks, the marks is -1, -2, -2, -1, 0, 0, 0, 1 to 1. So with the help of these marks, you can determine the horizontal gradient. And similarly, with the help of the another marks, you can determine the vertical gradient. So you can determine Gx and the Gy. And after determining Gx and Gy, you can determine the gradient magnitude. So gradient magnitude, already I told you, that is root over Gx square plus Gy square. So gradient magnitude you can determine. And also you can determine the angle theta. Theta is the angle, that is the direction of the edge normal. That is the direction of the normal to the edge. Direction of the normal to the edge, that also you can determine. So theta is equal to tan inverse Gy divided by Gx. So with the help of these marks, you can determine the gradient magnitude, m, and also you can determine the direction theta, you can determine. So another one is the Mohesh Bura. Can we please kindly highlight any practical application like human presence detection which in the use deep learning or ANN like sensor detection like proximity sensor or time of flight sensor? So this is by question by Mohesh. The practical application like the practical applications like human presence. So that means human presence, I can give example, instead of considering these sensors, I can, because sensor, if you use the sensor, then it will be an instrumentation system. But in case of the computer vision, mainly we have to use the camera. So we can use different types of camera, and this camera will be the camera takes the images, the camera can take the videos. So from the analysis of the images, from the analysis of the videos, we can determine a particular person is present in a particular spot or particular scene. That also we can determine. That is the object detection algorithm we can use. Whether the object is present or not, that we can determine. But you remember, we are using a computer vision system, so we are not using any sensors, but mainly we are using camera. So even we can use the thermal camera also, or maybe another camera, other type of cameras also we can use. And we can take images or we can take videos. From that input, we have different algorithms, different types of algorithms. We can determine whether a particular person is present in a particular scene or in a spot. That we can determine by using computer vision algorithm. So we can use the object detection algorithm or maybe any other algorithm we can use. But main thing we have to remember, we are using camera, not using another type of sensor like proximity sensor or other. We are not using. We are using the camera in computer vision system. So next question is, sir, can we elaborate algorithm used to region of interest finding in an image? Algorithm used in what is the question, sir? Can you elaborate algorithm used in ROI? ROI means, I think, region of interest. finding an image. So simple algorithm I can say, suppose in a medical image, suppose one tumor is available. So I want to determine the tumor, I want to detect the tumor. So first we can consider the segmentation algorithms, image segmentation algorithm. So we can do the segmentation, and based on some properties, the image properties like the color property, texture properties, or maybe the shape information, we can determine the region of interest. So this is a problem of image segmentation. So that is, image segmentation means the partitioning of an image into connected homogeneous region. So homogeneity is defined in terms of the predicate value. So in my class I discussed about the predicate, the concept of the predicate. So based on the predicate value I can do the segmentation. Segmentation means the partitioning of an image into connected homogeneous region. That is the definition of the segmentation. So already I have given one example. Suppose I want to determine the tumor in a biomedical image. So I have the CT scan image, or I may be the MRI image. CT scan image is available, MRI image is available, or maybe if I consider some X-ray images. So what I can do segmentation. And based on these properties, the image properties like the color information, texture information, or shape information, or maybe the combination of this, we can determine the region of interest. Similarly, in case of the endoscopic images, the colonoscopic images, so if I want to determine the polyp, so what I can do, I have to do the segmentation, and after doing the segmentation, we can determine the particular region of interest. So I think I could answer the question by, I could not pronounce his name, a bit. Okay, I am just waiting for your questions. So if you have any questions, you can put or you can write your questions in the chat box. Okay, I am online, so just ask me questions. So what I am planning, maybe next session, I will be offering one new course, mainly on machine learning and deep learning, or maybe artificial intelligence. Because this course is the computer vision, and one part already I discussed, the machine learning part. So maybe in my next course, I will be considering the machine learning, deep learning, or maybe AI. So I will be proposing one new course, maybe in the next session. So again, I am getting another questions. Prashant Purela, sir, is there be any platform for computer vision image processing to do projects for practice? Yes, you can see online platform is available, OpenCV Python. So like in Google Colab is also available. So if you apply some deep learning techniques, so you can use that one, the Google platform, Google Colab. But there are nowadays there are many online platforms. The cloud is available. But for learning of this, you can consider the OpenCV Python. So just you have to learn the programming, and OpenCV Python is very important for computer vision applications. And after this, you can go for some deep learning algorithms, the deep learning programmings, like the PyTorch is available, or maybe the TensorFlow. So these type of platforms are available. TensorFlow also you can use, the PyTorch you can use. So like this, there are many online platforms. So with the help of this, you can apply the deep learning algorithms. You can write the programs in deep learnings for deep learning algorithms. So you can see the mainly, but you have to see OpenCV Python. Okay, just I am waiting for your questions. So I'll be waiting for only another 10-15 minutes. After this, we have to conclude the session. So just you tell me your questions. So I think no questions. Sir. We'll be waiting for some time. So another 10 minutes I am waiting for your questions, and after this I will stop this online session. So how many participants, live participants? Or 12, let's say. Okay, I am receiving another questions. So, good evening. Agri Farm Industry Private Limited. Okay. Do you have any questions? So if you have any questions, then you can ask me. You can write your question in the chat box. Okay, again another question, the Mandip Pura. For human presence detection, which algorithm do you suggest from computer vision theory? So for object detection, you will get many algorithms. Even nowadays, the deep learning techniques are used for object detection. So there is not a single algorithm, but object detection, the first or object detection algorithm by Viola and the Jones. That is a very old algorithm, Viola and Jones algorithm. The face detection algorithm, Viola and Jones. So that is something like the hard classifier. So with the help of the hard classifier, we can detect the objects. But nowadays, there are many standard algorithms, particularly in the deep learning, for object detection. So presence of object in a particular scene, that we can determine with the help of these deep learning algorithms. So I told you, suppose one example, that face detection. So the very old technique, but that is a very good technique by Viola and Jones. That is something like the hard type classifier. So that was a standard algorithm for face detection. And that can be used for object detection also. So similarly, there are many algorithms, but I think you can see some research papers that just you type in the Google, you can search in the Google object detection in deep learning, by deep learning. So you can get this information, but if you search in the Google, you will get many research papers, many algorithms, not a single algorithms. So people are using different algorithms. The people are proposing many different algorithms. So you can get all this information in the internet. Just type in the Google object detection in computer vision. You will see many algorithms, and I should encourage you to use the deep learning techniques for object detection. So maybe you can consider the CNN, the convolution neural network, you can consider for object detection. So that is also very standard one. But if you consider the previous cases before the deep learning, so just you can extract some features from the image, input image, and based on these features, you can also determine the presence of object or not. Particularly, it is easy to do in the video as compared to image. So in the video, you will get many information, like motion information also you can get. So from the motion information also you can determine whether a particular object is present or not in an image. And the most simple one is the background, just the subtraction of two images. So if I subtract one image from another image, you can say that one object is present or not. This is the most classical, most simple algorithm for object detection. So if I do the subtraction of two images, you can determine that one. Suppose in one image, object is not present. In another image, object is present. And just you subtract these two images, you can get the object. So okay. So from agriculture, the industry private limited, sir, how can we use in agriculture? So in agriculture also there are many applications. So I am also the part of the SERB DST, the Department of Science and Technology. So we are getting many research proposals related to agriculture. So suppose the disease detection in agricultural plants. So from the images, you can detect the whether disease is present or not, or maybe the remote inspection of your agricultural products, or maybe the agricultural field. So remotely also you can inspect. So maybe you can consider the remote sensing or satellite images, or maybe some other images you can take. So this is one application. So in some of the proposal I have seen, like whether particular case is good or not, like moisture is good or not, and also you can determine the quality of the soil based on the color information, and also you can see the color of the leaves, whether it is a good or not. So that type of things you can determine with the help of computer vision. And different types of identification of the plants. So this plant is this plant is this. So identification of different plants also you can do with the help of computer vision. That is the automatic identification of plants, different types of plants, different types of leaves. you can do automatic identifications. The disease detection in the agricultural products. So you can use computer vision. So there are many applications of computer vision in agricultural domain. Another one is Sakhi Malik, sir, which feature extraction algorithm are suitable for disease classification in biomedical applications? So it depends on the applications. Suppose in biomedical applications, suppose if I consider the endoscopic images or colonoscopic images, the main point is we have to detect the tumors, we have to detect the polyps. So for this we can consider color information, because color of the polyp, the color of the tumor is quite different from the background. Or we may consider the texture information. So with the help of the texture information also we can consider. Or maybe we can consider specularity. Specularity means the mirror-like surface. So if I take some images, if I take some videos, then from the tumors, the reflectance property will be different, the reflectance property. So based on the reflectance property, that is called the albedo, we can identify a particular case. That is one example in case of the endoscopic images and endoscopic colonoscopic images or the videos. So if I consider suppose retinal image, the eye image. So for this you can consider different types of information. Maybe you can consider ages. Age is one important feature for these type of things. So you can determine the arteries and the veins. Suppose if I consider a cardio image, so cardiovascular images, so you can consider the arteries and the veins, determination of the arteries and veins. So this you can do. So based on the application, you can select different types of features. Or it depends on the applications. So now again, no questions from agricultural farm. So disease classification in biomedical applications, that is the case. So it depends on the application. So if you consider some biomedical applications like endoscopic image, colonoscopic image, you have to consider different types of features. If you consider, so suppose a retinal image, for this you have to consider different types of features. If I consider the X-ray image, the CIST image, suppose the detection of the COVID, in this case also you have to consider different types of features. Okay, then this from Agri Farm and Private Limited. Okay, so you responded like this. But I feel there are many applications in agriculture. So most of the cases I have seen the defect detection or maybe the disease detection in agriculture. So suppose if you take the images of the leaves or if you take the images of the plant, so from this you can say this is the disease. So it is not properly grown. So like this you can get all this information. Or suppose if I consider the quality inspection of the soil, the quality inspection of the soil, so that also you can consider with the help of computer vision. And suppose one location is good and one location the water is not available, so you can consider remote sensing images or maybe some other images like the satellite image you can consider, or maybe suppose nearby camera also you can put some camera and you can see the quality of the soil, the quality of the environment. Like this you can inspect. And also the product, agricultural product, the quality of the product also you can determine. Suppose the food quality, suppose quality of the apple. So based on some information like the color information or maybe some other information, suppose the shape information, like human being, we can determine the quality by inspection, whether this banana is good or this banana is not good. So like this we do the inspection, human can do. Similarly, the computer vision can be also applied for this. So again another question for demoscopic images, which features are best? So what do you mean by this? So just you tell me the one application. So I want to do this from this image and tell me, then I can tell the which feature will be good. But mainly nowadays, so instead of extracting the features, you can directly apply the deep learning techniques. So you need not extract features. Because in the traditional, the classical machine learning techniques, you have to extract features, and after this you have to go for pattern classification. But with the help of deep learning techniques, you need not extract features. Your input will be images, your input will be videos. So from the input image, your CNN or maybe the deep learning architecture, they will extract important information from the input images. So all the important information we can extract from the input images with the help of the deep learning architectures. So one example is the CNN, the convolution neural network. So just with the help of the filters, different types of filters, because first you have to do the convolution with the filters. So you take different types of filters, and with the help of the convolution you can extract important features from the input image. Then you need not separately extract features from the input image. That is the traditional or the classical machine learning. But nowadays people are using deep learning techniques. So feature extraction is not so important. So you can extract important information from the input image, from the input video with the help of the deep learning architecture. So we have another 5 minutes for this live session. So if you have any questions, then you can ask me. Okay. Sikha Malik. Thank you. Okay, again from the agri farm, sir, are learning the algorithm to crop management and like yield prediction. Yes. One is disease detection. Yes. Weed detection. Yes. Crop recognition. Yes. Crop quality very useful. Discourse. Thank you. Okay. It is the appreciation mail, appreciation message. So it is okay. So for all these applications, you are mentioning about all these applications. So for all these applications, you can use the computer vision techniques, the machine learning techniques. So like in DST, I have seen, I am the member of the DST committee. So I have seen many proposals from agriculture regarding these problems. One problem you mentioned about the crop management, like disease detection, weed detection, or the quality, the food quality inspection. So like this, we are getting many proposals, research proposals for this. So for all these applications, you can use computer vision. Yes, that is true. So we have another, I think, 5 minutes. So we have to conclude the live session. So I am requesting you, if you have any questions, you can put your question in the chat box. Otherwise, you can ask the questions to my TAs. What is the knowledge is required for algorithm designer? So the same question I am repeating again. The same question. The question is, so first is understanding of this course. Because without understanding of this course, without understanding the mathematical concept, you cannot do anything. So first you have to understand these basic concepts. After this, for applications, you have to know how to write the programs. So particularly in computer vision, you can consider OpenCV Python. That is also very important for industrial applications. But I am telling you repeatedly, understanding of the basic concepts are important. Suppose in an industry, you are getting one problem. Now you have to think what algorithm you can use. So your basic concepts are quite important. In this course, I have explained most of the basic concepts. And whenever you read a particular research paper, now it would be easy. So you download a research paper and you try to read the paper. But since you know all the basic concepts, so with the help of this basic concept, you can understand the paper. Roughly, you can understand. So that is why all these concepts, particularly the mathematical concepts, are quite important. So now you can download a paper from Google or maybe from IEEE Explore, and you can read the paper. Some of the concepts you can understand, and some of the questions you might not understand. Then what you can do, you can discuss with some other people, some expert, but you can understand. After reading the research paper, you try to implement this. So for this, you have to write the program. So program is mainly, I am telling you that OpenCV Python is one standard one. Or suppose if I use the deep learning techniques, so you can use the TensorFlow, PyTorch. So there are different types of different algorithms, different platforms are available. So with the help of these platforms, you can write the programs. But understanding of all these concepts are quite important. So if you read this, if you see my videos, if you go through this course, your understanding will be good. You will get all the basic concepts. For regarding the advanced concept, you have to download the papers, research papers. This is not a static course. You remember, this is not a static course. Like in some of the engineering, mechanical engineering, civil engineering, the courses are static. This is a dynamic course. Dynamic course means always the new things are coming regularly. So that is why I am telling that making the table of content, making the syllabus of this course is quite difficult. Because all the things are regularly changing. It is coming, new things are coming. So this is a very dynamic course. You will get many research papers. So today I am explaining one concept. That concept might not be good for maybe another 2-3 months. It might not be good. You will get many research papers. Many people are working in this domain. It is not a static field. So suppose if I consider one analog electronics in a particular course, it is not. I can say it is not so dynamic. But if you see these courses like computer vision, machine learning, artificial intelligence, these courses are very dynamic. So always new things are coming. So but if you understand the basic concept, then the new things also you can understand. So that is why it is really difficult to teach this course. Teaching of this course is quite difficult. Because what are the topics I should cover, what are the topics I should not cover, that is a very challenging thing. Always it is changing, all the things are changing. But whatever we are teaching, whatever available in the books, these are the most basic concepts that you need to understand. Then only you can understand the other concepts. So suppose in object detection or maybe another case, suppose face recognition, first you have to understand the basic concept. After this you download some recent research papers from IEEE Explore, or maybe in the Google also you will get some research papers, and you try to read the papers. And you can understand many concepts, you might not understand many concepts. And after understanding the paper, you try to implement in programming. So that is the idea of this course. So I am waiting for another 3 minutes. So this online session will be over because already only for 1 hour it is I'll be waiting just for 3 minutes. So if you have any quick questions, then I can answer quickly. Otherwise, we have to conclude the session. Okay, I think we can conclude the session. Thank you.